Happy Earth Day. I'm Rusty Lowe. I'm a project scientist with Globe Observer. Globe Observer is NASA's citizen science mobile app for Earth system observations. And today I'm going to be talking about the Mosquito Habitat Mapper, which is one of the data collection tools on the Globe Observer platform, which you can obtain in any app store that you choose to visit. Today, I'm going to tell a story about the first major epidemic in the United States. It took place in Philadelphia in 1793, and I'm going to set the stage here. The summer was hot. It was the hottest year that anybody could remember. The humidity was over the top. It was barely tolerable. And people were getting sick without knowing how or knowing why. So people were afraid. They were staying in their homes, afraid of contagion. They weren't going out in the streets. The streets were completely empty. Those people who had the resources to do so left the city to save themselves. And the death toll was extreme. 1 in every 10 Philadelphians succumbed to yellow fever. All told, around 100 to 150,000 people died from yellow fever in the next 100 years in North America in a number of cities. They didn't know why. They didn't know how to treat it effectively. Most people thought it was because of bad air, which they called miasma. And there's a parallel here between what we've just experienced with today's COVID-19 epidemic. Perhaps you remember last spring when we brought groceries in, we would wash the bags and wash all the containers in order that we wouldn't perhaps unintentionally contract the virus. You may remember the tragic story of a couple that was in Arizona that ingested aquarium cleaner because they had read on the internet that it was a cure for COVID incorrectly. And in fact, tragically, at least one of them didn't survive. It took 100 years, but now we know that yellow fever is caused by an organism that is the worst animal in the world. Some people call the Aedes aegypti mosquito, the yellow fever mosquito, the worst animal in the world. It's an invasive mosquito. It first came to North America in water barrels that were in the holds of ships that were carrying enslaved Africans during the transatlantic human trafficking and slave trade in the 1600s and 1700s and 1800s. They were reintroduced many times. These mosquitoes, these invasive mosquitoes, come from Africa, and they have a really interesting story. They evolved from a humble forest mosquito that would lay its eggs in tree holes. And at some point in prehistory, maybe 1,000 years ago, these mosquitoes identified the pots and the baskets that people were manufacturing in their villages as just the perfect place to lay eggs. And why was it perfect? Because it had still water, because it was dark and protected, and possibly because there were also co-located humans walking around that could provide that blood meal for females that needed to bite in order to feed the eggs they were developing. So this is the story of the yellow fever mosquito. Yellow fever mosquito was with us in the US until sometime around World War II, when DDT began to be applied widely as a pesticide. And it eradicated the yellow fever mosquito completely. But sometime in the 70s, we had stopped using DDT because it was toxic to many things besides just the things we wanted to kill. And sometime in the 1970s, the yellow fever mosquito hitchhiked once again on cargo ships from Africa, came back to the US, and established itself. And you can see in this map, the top map, that now we have this Aedes aegypti, this yellow fever mosquito, that has established itself permanently in some of these southeastern states. The thing that is challenging for us is that mosquitoes are responding to climate change, just like other organisms are. And as the climate is becoming warmer and the conditions are ameliorating for mosquitoes, they are actually expanding their range northward. And so in the lower map, you can see where we're going to expect to see this mosquito in the future. And so this is pretty challenging, pretty scary. A lot of you probably have heard the name Anthony Fauci, right? Because he has played such a important role in the U.S. response to COVID. Well, he's been involved in a lot of pandemic and epidemic research. Just a few years ago, he co-authored this paper, Yellow Fever Once Again on the Radar Screen, with a colleague. And what he's talking about is that yellow fever is once again potentially a problem that we might have to address in this country. If we've got the mosquito, so if we get the pathogen that the mosquito carries, we're going to have a problem. And this is where citizen scientists can come in, because using the Mosquito Habitat Mapper app, you can find and report those breeding sites. You can dump the water out of those breeding sites and protect your community, reducing the risk of disease because you're not letting those mosquitoes to develop into biting mosquitoes. And so you're also providing some data that scientists need in order that they can do more research and understand better where to find mosquitoes and develop those models that we need to better understand and protect communities from vector-borne disease. I want to point out that whereas the biting mosquito can be dangerous if it has a pathogen, the larvae, the immature mosquito, is completely safe. And so that's what we're looking at and recording using our app. I just want to show you here, this is what Mosquito Habitat Mappers have done over the past couple of years that we've had this app. We now have over 28,000 measurements. And these measurements are really important data that's now being used by our scientific community in a wide variety of different projects. So what I wanted to say here is that when you're using the Citizen Science Map, you're doing these really important things. You're letting people know, the scientific community know, your municipalities know, your mosquito control and public health organizations know where you're finding mosquitoes, what kind of mosquitoes that you're finding. And you can see that mosquitoes find all kinds of crazy places, different kinds of containers where these mosquitoes like to breed. So using the app, you just simply click on where you find that mosquito. And that is really important data. This is NASA. Why is NASA interested in mosquitoes? Can you see mosquitoes from space? Can you? The answer is, of course, no, you can't see mosquitoes from space. But what you can see are those conditions that we saw in Philadelphia in 1793 and that we see periodically as part of our weather system today. Times that are hot, times where you have high humidity, where you have precipitation events that allow mosquito populations to explode. And when you have exploding populations of mosquitoes, you also have populations of mosquitoes that can be potentially vectors of disease. This is the important thing. As a citizen scientist, you're making the connection between mosquitoes and space by using the Globe Observer app and describing the mosquito habitats, by using the land cover tool and describing what that environment is around where that mosquito habitat is located. You're going to help scientists put mosquitoes on the map as we see it in our satellite products. The end of the story. I really hope that you see mosquitoes. And if you are interested in finding out more of mosquitoes or sharing this with your family, we have a bunch of really cool activities and interesting resources that you can share by going to this link. And I just want to say thank you so much for listening and happy Earth Day from Globe Observer.